Hey geometry students, this is going to be a video to go through the graphic organizer for circles in terms of angles and how angles interact with circles. Now one thing that I want to stress here is we're also going to talk about arc measurements, and I know we haven't talked about like how we determine arc measurements and things, so this is some of that, but it's also going to be where arc measurements are given to you and you just need to use them, and we'll talk about them more later on again when we get back from break. So find that graphic organizer and we'll hop on in. Alright, so the first thing we're going to talk about here is the vertex being at the center of the circle. And we've looked at these angles before. They are also called central angles. Okay. Now, central angles, vertex at the center, what we're really looking for is how big this arc is from here to here around the circle and how that compares to this angle. So I'm going to use T, R, I as my letters here. And what we're really going to say for this situation, sorry, I was trying to figure out where I was pointing, is that this angle and this arc match up and that they are the same. So we're going to say that the measure of angle R is equal to the measure of arc TI. Okay. Whatever this angle is, this arc also is. And we'll follow that up with a couple examples. So we see that this is 55 degrees. All right. Now, we're looking for AE and AC. Well, AE is intercepted from that angle. We know that vertical angles are congruent, so we have 55 degrees right there as well, meaning that arc AE is also 55 degrees. Arc AC intercepts this angle. I'm going to do 180 minus 55 and get 125 degrees there, meaning that this arc is 125 degrees. Okay? And I got that because they're a linear pair. They're supplementary angles there. Okay. Down here, I know that this straight line is going to add up to 180, these two angles. So if this is 130, this angle is going to be 50, which means that arc ED is also 50. Now, mark EAB, sometimes we use three letters because we have to go through that. There are multiple ways to get from E to B. I could go this way around the circle or this way around the circle. So EAB says I start here, go through point A, and around to point B. One of the cool things is that I recognize that this is a straight angle, which means it's 180 degrees, which means this arc is 180 degrees. It's a semicircle or half of a circle. The key point here is that in central angles, the central angle and the arc that it intercepts are congruent or the same size. Okay. We'll slide over here to seeing the vertex on the angle. You'll also see these called inscribed angles. And they are inscribed because their vertex is on the circle. And we use that word on right there. Now, I'm going to use R, U, N there. If you want to use other letters, you can. The idea with inscribed angles, as we draw this vertex across, okay, I want you to see that those two segments are going to get dragged as well, and that angle is going to get smaller. Okay? And we're going to see that the measure of angle U is equal to 1/2 of the measure of arc RN. And we're going to see that anytime we have an inscribed angle, it's going to be half of the arc. Okay? So when it was a central angle, it was the same as the arc. When it's inscribed, it's going to be half of the arc. Okay? And all that means is when we jump down here, for this part, for x, the angle is half the arc. It's exactly how I'm going to set up my problems here, by reading and translating that. The angle is half of the arc. Well, I can either do 50 divided by 0.5 or times 2 on both sides. But either way, the arc is going to be 100 degrees because the angle is half of that. 50 is half of 100, excuse me. Same thing down here, but now it's going to be the angle is half of the arc. And that's an easy multiplication. Half of 40 is 20. We'll see the same thing down here with a triangle. You just have to be really careful about the intercepted arc. So x opens up to intercept from here around to here. Okay, if I follow the lines from x out, I've got a point there and a point there. So x is half of 88 degrees. Okay, sometimes it's a little tough with a chord there to see which part's being intercepted. So we just follow that out. That makes x 44 degrees. Now y, if I follow, intersects here and here. Now what I want you to see is that y is intersecting the diameter. And what we know about that is that that arc on the other side is 180 degrees. It's not written, but we know that when we're talking about a diameter, that's going to cut the circle in half. So y is half of 180 degrees. Means that's a 90-degree angle. So a right angle is considered to be inscribed in a semicircle. That's how we would read that. Right? Now, we're going to put that vertex inside the circle. So as I'm dragging that vertex towards the side, I could stop it in the middle here, and that's the situation that I get. The important thing here is to recognize that vertical angles are congruent. Okay? So B, R, A, I, N for brain. But what we're going to see here is that the angle is half of the sum of the arcs. Okay? So the measure of angle BNR equals half the measure of arc IA plus the measure of arc BR. Okay? So that angle cuts off this arc on that side of the circle, and the same angle, they're congruent, cuts off this arc on the other side. So from I to A and from B to R. When you see it down here, 75 is on this side, 115 is on that side. So x is going to equal half of 75 plus 115. That means x is half of 190 degrees. And that's going to give us 95 degrees. Okay. Again, we're adding those two and cutting it in half. We're averaging the two arcs. We can even do that if the angle is given to us and we're looking for an arc. The angle is half of the sum of the arcs. Doesn't matter where the variable is, we just go with the sentence. The angle is half of the sum of the arcs. Well, I want to get rid of that fraction. I'm going to multiply both sides by 2. 100 equals 80 plus x. And then I subtract 80 from both sides, and 20 equals x. It's 20 degrees. Okay, algebraically, there are maybe a couple other options, but that's really one of your easiest. And then lastly, what happens when the vertex has been dragged so far that it's outside of the circle? So I still need 5 letters here. And we're going to go with generic 5 letters, X, Y, Z, W, and let's say K, just for fun. When it was inside, we added the arcs. When it's outside, we're going to subtract the arcs. Okay. And so we're going to see that the measure of angle Z equal to 1/2 this bigger arc right here, measure of arc XK, minus the measure of arc YW. It's the smaller arc right here. And so it's a very similar process. We're just going to translate the angle equals 1/2 of the larger arc, which is 75, minus the smaller arc, which is 15. And those are all degrees. I should put that over here as well. The angle is half of the difference of arcs. So x equals 1/2 times 60, means x is 30 degrees. Same thing down here, you just got to be really careful of that point of tangency, okay? Because these make up the whole circle, so 360 minus 270 gives us 90, meaning that the angle equals half 270 minus 90. You just have to figure out what that is because it's got to make up the whole circle. X equals half of, that is 180 degrees, means that x is a 90-degree angle. Okay. Make sure you have that all. There will be a couple more videos coming with some work, and we'll talk to you soon.